Question 1. So we have I'll call it container A is equal to container B. Right? Container A has 8 milliliters of water, is leaking at 6 milliliters per minute. So we start at 800, and because it's leaking, we're losing 6 ml per minute. Container B starts at 1000 and it's leaking at 10 per minute. Right? And that's so if you think about it, let me take container A for example. If it's 1 full minute, it will lose 6 milliliters of water, and you would have 794. That makes sense, right? Well, let's say 2 minutes pass. Well, then it would be 6 times 2, and after 2 minutes, it lost 12 milliliters of water, and your answer would be 788, right? So notice that container A is looking at, it's leaking at a smaller rate than container B. Container B is leaking at a much faster rate, but then again, container B starts at a higher quantity. Now, at some point, if we have 2 containers, and I'll even draw them out here, container A, and I'll make container B just a little bit bigger because they're full of water. Now, there's a little, I don't know, what do you call that? Valve here, right? It's open. You open it, and water starts coming out. Right, they're both going to decrease, but at some point, right, they're going to have the same amount of water. Now, the question is, how long will it elapse for them to have the same quantity? Well, let's solve this. I'll go back to all the things that we have to look for. Distributive property, no. Combine like terms, look on the left. No, I can't combine. Look on the right. I can't combine these two because they're not like terms. They're variables on both sides. Get rid of the one with the lower, smaller coefficient. Well, one coefficient is -6. The other one is -12. Which of these is the smaller number? -10. By doing this, you take away the problem of dealing with negative numbers at a later step. So let's see what that looks like. So I'm going to add 10m over here to get rid of that. And if I add 10m to one side, I must add 10m to the other side. -10m plus 10m, this becomes 0. So we don't really need to write that because 1000 comes down, and there's no reason to write 1000 plus 0, right? So that's why they goes away. On the other side, we have 800. -6 plus 10 is +4m. Now you have a simple two-step equation. We're going to take away 800 from this side. We're going to take 800 from this side, right? We're going to try to isolate our variable. So get rid of the 800. Now we have 4m left over, and we have 200 over here. Now, one more step. We're going to divide by 4, divide by 4, and then 4 divided by 4 leaves us with the variable isolate completely alone. Just a single m. And on the other side, we get 50. So at 50, and now here's where I do my check. At 50, when m equals 50, 50 minutes have passed, container A is going to have the same quantity as container B. Well, let's double check that. So 800 minus 6 times 50. Let's see what that equals to. Well, 800, 6 times 50 is 300. And we're going to have 500 milliliters of water in container A. So at the other container, 1000, and minus 10 times 50, it's 1000 minus 10 times 50 is 500. And look at that. After 50 minutes, right, both containers have the same quantity. 2, now there's the same type of problem but different context. There is a phone service, singular, and the other one is Verizon. And we want to know how many minutes would you have to spend so that you pay the same price regardless of whichever phone company you use. So the first one charges $39.99. You pay that regardless. And then every minute you pay 45 cents times M. For Verizon, it's $44.99 upfront plus you pay 40 cents per minute. So, excuse me. In one plan, your upfront price or your monthly price is lower, but they charge you more per minute. The other one is you pay that monthly fee. It's higher, but the minutes per minute is cheaper. So they're saying, well, at what point would they, how many minutes do you have to speak so that it wouldn't matter if you chose singular or Verizon? I don't even know. I think singulars exist anymore. Well, same idea. We have 0.45 and 0.40, so we're going to get rid of the small one. The smaller coefficient is this guy. So minus 0.40 m, and I'm going to subtract minus 0.40 m here. Those two go away. On one side, I'm left with 44.99, and this I'm going to be left with 0.5 m, right? And then, sorry, I forgot the 39.99. Now, again, we want that to look like this, so I got to get rid of the 39.99. Okay, so I'm going to subtract 39.99 from both sides, and that becomes 0. I'm left with 0.05 m, and this is going to be 11. We don't need to put the 0, but I just wrote it for now. So now let me bring that up. So we have 0.05 m equals 11. I'm going to divide both sides by 0.05 and divide this side by 0.05. So 11 divided by 0.05 is 220 minutes. So if you knew ahead of time that you were going to talk for 220 minutes on your cell phone, then it wouldn't matter which cell phone company to use, because you would end up paying the same amount. Okay. All right. My God, these questions are old. So iTunes charges. So all right, I for iTunes, and then Napster. Oh my God. iTunes, it's 99 cents per song. The cost of purchase from iTunes is 99 cents per song. So they charge 99, and I'm going to write X instead of S, okay, per song. Napster, on the other hand, is $10. You have to pay $10. Okay, and if you don't and then even if you don't download any song from Napster, you still would pay $10. But for every song that you download, it costs you 89 cents. 0.89x. So which one would you rather do? So, they use the variable t. I'll just use x. So how many songs do you have to purchase so that it wouldn't matter which service you use? Well, again, there's no distributed properties, there's no combined like terms. Let's get rid of the 0.98x and minus 0.89x. This goes away. I'm left with 10. This is just 10 cents. Divide this by 10 and divide this by 10, right? So X would be 100 songs. So if you downloaded 100 songs, it doesn't matter if you chose iTunes or Napster. But again, think about it. If you chose, if you knew this month, I'm only downloading 5 songs. Would you do Napster or would you do iTunes? Well, with iTunes, it'd be 99 cents times 5, so you would end up paying like $4.95. With Napster, if you only downloading 5 songs, you would pay $10 plus 89 cents times 5, and obviously iTunes would be the ideal, right? So again, at 100, it doesn't matter. Any other point, any other number of songs, it would matter. Either, depending on the quantity, you might choose one service over the other. Container A has 2, so let's call that A, and again, container A starts at 200, and it's being at 6 liters per minute. So after 1 minute, it has 206. After 2 minutes, it would be 200 plus 12, right? Because 6 times 2 would be 12, so it increases by minutes, 6 liters per minute. And the container B has 500, right? So, but this one is being drained, so it's losing 6 liters per minute. At what point, right? So you have a container, this one is decreasing, and this guy here is empty, and the water is going up. At some point, they're going to be at the same level, and that's what we're trying to look for. Again, there's no distributed property, there's no combined like terms, so our first step here is, and the next step here would be to get rid of one of the variables. There's 1 on each side. Let's get rid of this one because that's -6, which makes it a smaller coefficient. So we do the opposite, the additive inverse, which is plus 6m, and we do plus 6m on this side. That goes away. Left 500, and over here I get 200 plus 12m equals 500. Now, it becomes very repetitive, right? Minus 200, minus 200. This goes away. 12m equals 300. We're going to divide both sides by 12, and m equals 300 divided by 12 is 25. So after 25 minutes, both containers will have the same amount of water. UPS and FedEx, okay? It charges $7 for the first pound, so plus 20 cents for each additional pound. That's UPS. FedEx charges $5 plus 30 cents for each additional pound. How many pounds P will it take for UPS and FedEx to cost the same? Well, so if you're sending something, right, and again, depending on the weight, you might choose UPS over FedEx, but there's a particular weight here that it wouldn't matter which service you would choose because it would end up costing the same, and that's what we're trying to look for. So right in the middle, let's get rid of this one because it's a smaller coefficient. We go minus 20p, minus 20p. This becomes 0. 7 comes down. 5 plus and 30 cents minus 20 cents is 0.10 or 0.1. Let's subtract the 5, right? So we're going to do minus 5 minus 5. 7 minus 5 is 2, and over here we're left with 10p. Divide both sides by 10, 0.10, sorry. And the pounds, the weight itself that we're looking for is 20 pounds. So if you had a box that weighed 20 pounds, it would cost the same amount whether you sent it with UPS or sent it with FedEx. And again, you could check. Right, so 7 plus 0.20 times 20. And then this would be 7 plus 4. And that would, UPS would give you $11. On the right side, again, let's try 5 plus 0.30 times something that weighs 20 pounds. 5 and 0.30 times 20 is 6. And again, 11. Notice, right? So if you're, it would cost, so if you had something that weighed 20 pounds, FedEx would charge you 11, and UPS would charge you 11. So it wouldn't matter who you serve, who you chose. 12-inch candle. There's an 8-inch candle. 12-inch candle and 18-inch candle lit at 6 p.m. 12-inch candle, sorry, burns, so it starts at 12, and we're losing 0.5 inches per hour. The other one is 18 inches, but it burns 2 inches per hour, minus 2 inches per hour. At what time will they be at the same height? Well, that's what we're trying to figure out. So again, these questions, so far, no distributive property, no combining like terms, so we go straight to getting rid of one of the variables. So you either get rid of negative 2h or 0.5h, and we're going to get rid of negative 2h because negative 2 is less than 0.5. So plus 2h, that goes away because it comes 0, 18 comes down, and here we have 12 plus 1.5h, right? Let's go to isolating h now. We can subtract 12 on this side, minus 12, and 12 on the other side. That goes away. I'm left with 1.5h equals 6. Divide by 1.5 and divide by 1.5. So h equals 4. So in 4 hours, these two candles will be at the same height. Okay, so again, very repetitive, right? But you know, it's just once you have the setup, everything else is easy. Bill weighs 120 and is gaining 10 pounds each month. Yikes. Phil weighs 150 and is gaining 4 pounds each month. How many months will it take for Bill to to be the same weight as Phil. Hopefully they're working out and they're getting muscles. So here's Bill, and there's Phil. Bill is at 120, and he's gaining 10 pounds per month. Sorry, per month, each 10 times M. And here we have Phil, who's 150. Right, it starts at 150, and every month you're going to add 4 for him. How long will it take for them to weigh the same? Well, let's figure that out. We're going to do minus for him, minus for him. These two go away. 150. This is 120 plus 6M. Subtract 120 from both sides, and we're going to write 6M equals 30. Divide both sides by 6. M equals 5. So in 5 months, they will be the same height. And again, I didn't ask you today, but we're going to go back to the original equation. We can substitute and figure out what weight that is. And we're going to, so again, 120 plus 10 times 5, right? I'm replacing the M with 5, equals 150 plus 4 times 5. It should be exactly the same. So 150 plus 20. On the right side, I get 170. On the left side, it's 120 plus 10 times 5 is 50. And I also get 170. So in 5 months, they both will be 170 pounds. This one, we have 2 Cokes. Actually, we have 2 cans of Coke. So one is being, and here's the empty one. This is full, by the way. Right, and that is being poured into this one. So this one is losing soda, and this one is gaining. So at what point can I stop pouring so that they have the same amount of Coke? Let's say you want to share with somebody. So the first can starts at 355 milliliters, and it's losing 5 milliliters per minute. The other can starts at 0 because it's empty, but it's gaining, I'll write 5 milliliters per minute. You know, you don't have to put the plus, but I just want to put it there so you know that it's gaining. Okay. Same thing. No distributed property, no combined like terms. Lucky for us. Let's get rid of the variable that has a lower coefficient, which is negative 5m. In order to get rid of negative 5m, I'm going to add 5m. And I'm going to add 5m on this side. That goes away. 355 comes down because that's the only thing left over. And here is 10m. So divide both sides by 10. And in hang on a second. So the answer is, 35.5 minutes. Okay. Let me just double check something. 35. Yeah. Yeah, that's correct. And again, you can go back to the original equation, substitute, and make sure the left equals the right, and you'll see that it does. 9. Super Bowl. Renting shoes. What is it? Oh, you bowl. Okay, so this is Mar, and then this is Pins. At Mar, the shoes cost $2, plus you got to pay $3.50 per game. At the other place, the shoe rental is higher. It's $5, but each game is $3.25. So again, I'm forgetting a G somewhere here. Over here, let's say we have to get rid of one of the variables. So one we have 350, the other is 325. So the Small one's 325. Let's get rid of that one. Minus 325 and then minus 3.25 G. That goes away. 5 is left over. Here I'm left with 2 plus 0.25 G. Right? Next step is subtract 2 on this side, subtract 2 on that side. Let me bring this over here. We're going to have 0.25 G left over, right? Because these two go away. And on the other side, 5 minus 2 is 3. Divide by 0.25. Divide by 0.25. How many quarters? Where's the G? Yeah. And how many quarters are $3? Well, that'd be 12. One store trophy costs $12.50. Engraving costs 40 cents per letter. And the other store trophy costs $14.75. But the letter engraving is 25 cents. How many letters must be engraved for the cost to be the same? So $12.50. And it costs 40 cents per letter, and I'm going to write X because I don't like the letter L. And the other one starts at $14.75, and they're going to charge us 0.25 cents per letter. Okay, so again, minus 0.25x minus 0.25x. That goes away. 14.75 is left over here. 1250 plus 0.15x. We're going to subtract 1250 from the right, from the left side, and then 1250 from the right side. That goes away. I'm left with 0.15x equals $2.25 divided by 15 divided by 0.15. Apologies, and x equals 2.25 divided by 0.15. I think it's 15. Yes, it is. So x equals. So if you were to engrave 15 letters, you could go to either store because it would be the same expense. Okay. You're seeking to be emancipated from your parents. Oops. You're looking for an apartment. There are two final choices. Apartment A has 1,000 security, which is not bad, plus $1,200 per month in rent. All right. Apartment B, you have to put down $1,500 security, and then you're going to pay $1,175 per month. So, how many months will they be the same cost? Well, smaller coefficient between 1,200 and 1,175. It's 1,175. So I'm going to subtract that here. Here. These two go away. 1,500 comes down. This becomes 1,000, and then plus 25m. So let's work on isolating m because I want my expression to look like that, my equation to look like that. So minus 1,000, minus 1,000. That goes away. I'm left with 25m equals 500. Now divide this by 25. Sorry, divide this by 25. M equals 20. So in 20 months, or a year and 8 months, okay, the cost will be the same. Honey makes $55,000 plus 2,500 a year in raises, and the other person gets $62,000 plus 2,000 yearly bonus. So where would you rather work? Well, let's get rid of the 2,000y because 2,000 has a lower coefficient. Minus 2,000y on this side. That becomes 0. I'm left with 6,200 on the right side. On the left side, I have, 62,000. Yes. On the right side, I'm left with 55,000 plus 500. Why? Okay. I'm going to subtract 55,000 from this side, and I'm going to subtract 55,000 on the other side. That goes away. I'm left with 500y equals 7,000. Divide by 500, divide by 500. Y equals, I believe that's 14. Yeah. So in 14 years, right, if you knew you were going to work for 14 years, then it wouldn't matter which company you chose. Okay. When we do systems and we're graphing, you'll see, right, that when you graph that, one line might be like this, and the other line you're making goes like this. They change colors. Right, so that's our answer, right? At this point in time, it doesn't matter which company you work for, but after this date, you want to be in the blue company, right? Because you'll notice that you'll be making more. But before this date, you don't want to be in the blue company. You want to be in the black company, not black company, the black line represents the other company, okay? Because you're making more. So if you know how many years you're going to be working, if you knew that ahead of time, you could decide, hey, you know what, I want to work for this company here, company A. Let me call that A. I'll call the other company B. So company A, notice that before this particular time, you make more, and after that time, you make less. 13. Oh my God. 34,700,000 on the dog, and then all decreased by sorry, I can do this. Oh no, my pen. Okay, here we go. No, sorry. 34. These are the dogs, and come on. And these are my cat people, and we're decreasing 0.025 per year, right? The dog ownership and cat ownership, really. Cat ownership was at 27.7 million, and it's increasing 0.375 every year. So one, dog ownership is decreasing, cat ownership is increasing. Ugh, really? I've had both. I'm not too sure which one I would prefer. Oh, that fur. Granted, there were 5 cats, so it's a little excessive. All right, let's get rid of this guy. Plus 0.025, right? Again, if you don't want to deal with negatives, you can always get rid of the variable that has a smaller coefficient. So, and then again, plus 0.025. This becomes 0, so I'm left with 34.7 million, okay? And then 27.7 million plus 0.395y. We're going to subtract 27.7 million from both sides. And I'm going to continue up here, okay? 37.7 minus 27.7 equals 7. So here we've got 7 million equals 0.395y, right? Yeah, okay. And then we're going to divide both sides by 0.395, 0.395, and y equals, let me divide that, 7 divided by 0.395, you get 17.72. Okay, so that's oh no, I made that wrong. So that's wrong, that's wrong. So what I did was I didn't add these correctly. So on here it is 7, right? 37, so I put a subtraction sign, sorry. 34.7 minus 27.7 is 7. But on this side, this goes away, and I had incorrectly added this. So this is 0.375 plus 0.025, which should have given me 0.4y. There we go. And that's what we have. So now I'm going to divide 7 divided by 0.4. Right? Divide this by 0.4. Divide this by 0.4. The number of years it's going to take to have the same amount of dogs and cats, it's going to be 17.5. In 2000, the highest population was 11.4, and it's increased to 11.4 million, and it's increasing by 0.5 million per year. Michigan's population was 9.9, and it's increasing by 0.6 million per year. When will those two states have the same population? Well, we'll find out. Again, let's get rid of 0.5. So I do minus 0.5, and I do minus 0.5 over here. This goes away because it becomes 0. 11.4 comes down, and now I have 9.9 plus 0.1y. Let's subtract 9.9 from each side. Right? This goes away. 0.1 comes down, and then 11.4 minus 9.9 equals 1.5. Let me take that to the side. So we have 1.5 equals 0.1y. We're going to divide both sides by 0.1. And that's going to give me that y equals 15. Okay, so in 15 years, the population of Ohio and Michigan will be the same. Okay, and again, we should have gone and substitute y was 15 over here, and this y to 15 to make sure, double check that our equations are correct. Okay, but this is a good workout here. All right, that's it.